What's happening, dogs? Mr. Allen here, finding some zeros of polynomial functions given a graph and its function. Ooh, this is interesting because usually I would think, hey, 4 terms, factor by grouping, let's solve. But this one is not factorable by grouping. Okay, it won't work out. Not every function or equation is factorable. But for this one, we're given its graph, and we've got one for sure accurate 0 here at 2, 0. These other two are in between, so we can't really assume like, oh, is this negative 1, 2, 3, 4, 5? Is it negative 5.5? I don't know for sure unless it's labeled. But if it's crossing through at an exact spot, it would be okay to assume. That'd be a real jerk move if we said, no, nope, it's not. It's just a little bit off. No. Okay. Anyways, so definitely crosses at 2, 0. And if I divide out one of my zeros or one of my factors from a cubic polynomial, I'll be left with a quadratic polynomial. And I've got options to solve quadratics, right? Quadratic formula, factoring. Those are my two go-to. Hopefully factoring, but if I have to, I can use quadratic formula. So let's divide this guy out, and I'll use synthetic division to do so since it's just a linear factor there. Boom, 2 goes up in the box. It's what x equals goes up there. And then I got all my coefficients, 1, 2, negative 16, 16. Okay. If there's ever a missing term here, make sure you put a 0 in its place. Now I can drop the 1. And I'm just going to multiply through. 2 times 1 is 2. And then I add them. 4. Multiply, I get 8. Add them, negative 8. Multiply them, I get negative 16. Add them, I get 0. And that makes sense because this is my remainder, right? My remainder should be 0 if 2 is one of my zeros, right? If 2 is the 0, my remainder should be 0. It should divide out clean. If you get anything but 0 in a situation like this, you did something wrong. You may have written these numbers down wrong. You may have done the process wrong. You might have put the wrong number here. All right, you should get 0 for the remainder because it is a 0. Cool? Awesome. Now, this right here is my constant, my x, and my x squared. So let's write that down. I've got x squared plus 4x minus 8. And I want to solve this thing. Set it equal to 0 and solve. Go-to is factoring, right? Is anything multiplied at negative 8? And add to 4. We got 1 and 8. We got 2 and 4. No dice. Time to bust out the big dog, the quadratic formula. Okay. So we have x equals the opposite of b plus or minus the square root of b squared, so 4 squared, minus 4 times a times c. All over 2a. So make sure that fraction goes all the way here, including that negative 4. A lot of kids just put it under the square root. That is not correct, right? Because this negative 4 is also being divided by this denominator right here. So make sure you don't get lazy. Put that thing all the way along there. I see kids lose points for that all the time. I'm just trying to help you out, man. I'm just trying to help you out. All right. Negative 4. Let's clean up the inside here. So that's 16. So whenever I'm doing this by hand, this would be like a non-calculator problem. I'm going to see that I have negative, positive, negative. 2 negatives make it positive, so I know this is addition here. And then I'll do the numbers. 4 times 1 times 8, that's 32. All over 2. Let's continue. This is just such a wonderful formula, isn't it? So great. It's kind of cool when people derive the formula too. It's interesting stuff, you know? Interesting. I know, I'm a math teacher, I'm a math nerd, so I found it interesting. You might not find it that interesting. You might just be like, bro, let's just get this problem done because I got a test tomorrow and I got to learn how to do this. Okay. Square root of 48. I can break that down, right? I'm going to do a little side math so we can just continue nice and smooth here with the quadratic formula. We'll actually do a little side math in here. So square root of 48 broken down, that would be, I can divide that by 2 and I get 24, 2 and 12, 2 and 6, 2 and 3. Pair of 2s, pair of 2s. That means we're going to have 4 square root 3, okay? So there are different ways of breaking down your radicals. That is one way of doing it. You could also look for perfect squares. We could have broken that apart into 3 and 16. Square root of 16, that's 4. We get 4 root 3 either way. I favor this because then it works well for cube rooting and fourth rooting and so on and so forth. Just prime factors. I always start with 2 if possible, and I continue with 2s until I can't, and then I go to 3s, 5s, 7s, and I keep it nice and organized in that line. Okay, back over here. We have negative 4 plus or minus 4 square root 3 over 2. Can I simplify this? Yes. Okay. I would say this is probably the toughest scenario of this style problem, because if we had to use quadratic formula and it was not simplifiable, like that was like a 41, okay, then we would just be done. That would be our other two zeros here, right? But because we can simplify and now we can simplify again, makes the whole process a little bit more cumbersome, if you will. All right, so everything's divisible by 2 here. So I'm going to say that x equals -2 plus or minus 2 square root 3. The 2 gets divided by 2, so that's it. So this is to be 2 of my zeros, and the other one is just going to be the one that was given to us. But don't forget to write that down, because that'd be a real bummer if you lost a point because you didn't write down the easy one, right? It says find all zeros. These are all 3 of my zeros. 1, 2, 3, right? The plus or minus, that counts as 2 zeros right there. All right, guys, that's it. So synthetic division for the win. Make sure that you're matching it to what the x equals. If I gave you a factor, then you'd have to set it equal to 0. It's going to be the opposite sign. But synthetic division usually works out very well for these. Long division if it's a different factor, but most of these types of problems we usually give you will work with synthetic division, because that'd be a whole process if you also had to use long division. Ugh. Anyways, all right. That's it. Thanks for watching, you guys. Make sure you like, subscribe, and have a dope day.